that you have from the homework. Happy to address anything. So those of you guys at home, on Zoom, those of you here in class today, to do that again, man. Just take it off, man. Come on, let's see it. No? Yeah.
A few questions here online.
I'm ready.
Yeah, 57 and 23.
Okay. Number 57?
Yeah.
Okay, and number 23?
Yeah.
Let's see here. Action Jackson. Will you read 57 to me?
Okay, so it says 8y plus 2x equals -4.
8y plus 2x equals -4. Okay, what's number 23?
Let's see here. 23 is, so in parentheses, 2 common 9. And then it says the equation is y equals 3x minus 1.
Getting crazy, yo?
The glare is a little bad.
Mm-hmm.
So I'm going to switch it.
Number 19. Okay, so it says determine whether the given ordered pair is a solution of the equation. Okay, so is this ordered pair a solution to this equation? Okay, is this ordered pair a solution to this equation? Okay. Everybody, we're going to add some things to our notes today on basics. We're going to do this right now. So, if you're asked if this is a solution to the equation, I want to talk to you. I'm going to come to the far right board here. In the math world, we have what we call an equation. An equation, an example would be, okay, so an example would be y equals 3x minus 1. Okay. I'm going to give you a different example. We'll go ahead and we'll jump back to the exact same example we did. 2x plus 3y equals -6. We graphed that last time using the plug and chug method. And we're going to use this same equation over and over again to kind of exemplify all the things that we're learning. In the graphing world, okay, and you can write while I'm writing right now, and so we're going to put this again. This goes, we have 4 pages that we dedicated to our notes. We had a basics page, a graphing page, a slope page, and an equations page. So you're going to jump to your basics page right now, okay? Let's do that. Mauricio, you there?
Yes, I am.
You on your basics page?
I'm going to take a picture. I forgot my notebook.
Oh, that's good, man. Pictures are good. Okay. And so in the graphing world, if we graph this equation, all right, we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So last time that we met, we said, you know, let x equal 0. We had 2x plus 3y equal -6. We put in a 0 for x. Is canceled. We got 3y equal -6. We divide by 3 and divide by 3. We got y equal -2. We had a single ordered pair. How many points do we have right now? Loud.
1.
1 point. How many do we need to graph a line?
2.
2. Always 2. And 3 or more is a waste of your time, right? So we can plot this point. We go 0 this way and -2. We're right there, okay? So, you ready for this? Can we move our knowledge a little further along here today? So we can pick another value of x, yes? And we pick any value that we want, all right? Now, if you pick 1, all right, then you're really, really close on the line here, where I said if you go a little bit further out, a few away, one way or the other, in the negative range, the positive range, you get a more accurate depiction of your graph. Okay. You can let x equal 3. We could say, all right, well, 2 times 3 then, plus 3y equals -6. We get 6 plus 3y equals -6. We subtract 6 and subtract 6. We get 3y equals -12. We divide by 3 and divide by 3, and y equals -4. And I believe that one of you recommended that we did this number in class last time, because I'm pretty sure we got that last time. So we come in here, we got 1, 2, 3, and -1, 2, 3, 4, and we're right there. This is kind of nice because we didn't have any fractions to deal with. We connect the dots, and there's my line. So these two things mean the exact same thing. Math is the manipulation of numbers to look different but remain the same. You sound so vain this morning. We talked about pee dribbling down your leg last time, and basketball players, and 11-year-old and 12-year-old girls playing hoops, and all that good stuff. And here you are today, moaning again. Same. Okay? All right. Math is the manipulation of numbers to look different but remain the same. These two things are the exact same thing. This is it in the math world. It's an equation. This is it in the graphing world. What's this called? What's this called? A line. That's right. That's what this whole chapter is about. Lines, right? We joked about that, drugs, all that kind of stuff. And so in the graphing world, this is called a line. So an equation and a line mean the same thing. Okay? In the math world, we would call solutions to the equation, like 0 and -2 is a solution to the equation. 3 and -4 is a solution to the equation. In the graphing world, we have them right here. What are those? What are they? They are what? They're ordered pairs. Very good. What else? An ordered pair is the artist formerly known as point. Okay, right? So remember Prince? Do you remember Prince? Does anyone know who Prince was? No? I don't know, he changed his name or something. He became the artist formerly known as Prince. But okay, an ordered pair is also known as a point. Okay? So let's look at this. These are points, okay? These are points on our line. Okay? Now watch this, okay? All pens and pencils down, all heads up at home, at here. Let's watch this and let's learn. Because this is a powerful concept here, okay? 0, -2. Let's plug 0, -2 in here. Let's do it. Okay, go ahead, do that right now. So let's think about it for just a second. These are your values of x and these are your values of y. I want you to plug 0 in for x and -2 in for y. Okay? So we'll get 2 times 0 plus 3 times -2 equals -6. This cancels, you get -6 equals -6. Did you get that? Yes or no? Is that a true or a false statement?
True.
It's a true statement. So a true statement constitutes a point on the line. Okay? Let's do it again for 3 and -4. Plug 3 and -4 in. Okay? So you'll have 2 times 3 plus 3 times -4 equals -6. So you'll end up with 6 minus 12 equals -6. What's 6 minus 12? -6. So we get -6 equals -6. Okay? Again, a true statement. Again, a point on your line. Okay? Now, let's pick a point on this graph that is definitively not on this line. Give me an ordered pair up here that's not on this line.
1, 1.
1, 1. Okay, so we go 1, 1 right there. That point, I agree with you. That 1, 1 is definitely not on our line. I want you to plug 1 and 1 in for this right now. Go ahead and do it. It's pretty easy. It's going to make 2 plus 3, which is 5. Does 5 equal -6?
No.
Heck no. You see what's happening here?
Yep.
Points on the line make true statements. Points not on the line make false statements. Yeah? So we come here and we put in 1, 1. Okay? We put in 1, 1 there. And we say, yep, 2 times 1 plus 3 times 1 equals -6. Nope, we get 5 equals -6. That is not true. No Fumar. Don't smoke that, right? Okay? Let's come back to the middle board. Is this ordered pair a solution to this equation? Do we need to graph this? No. What can we do? Plug it in, plug it in. Here's x, here's y, okay? And so we will take, where there's a y, we say 9 equals, where there's an x, we'll put in a 2, and say minus 1. So we get 9 equals 6 minus 1. 9 equals 5. Does 9 equal 5?
No.
No, it does not. And so this is not a solution to this equation. But I also want you to understand, if we did graph this, go ahead and graph it. Y equals 3x minus 1. Do it right now, okay? Just take a minute and graph it. Okay? Use the plug and chug method. Graph y equals 3x minus 1. How you doing, Stefan?
I'm rocking it.
You are rocking it.
It was a good weekend.
Oh, mine was a good weekend.
Yeah.
Mine might have been better than yours.
Really?
I don't know.
What'd you do?
Can't tell.
Hmm.
I'd tell you, but I'd have to kill you.
Oh.
Yeah, that's a James Bond move, you know what I mean? You want to know something fun?
What's that?
So, when COVID hit, I bought a membership to a local gym, you know, because the gym here, you know, kind of shut down, right? At BYU Idaho. And I still don't like going to the BYU Idaho gym because they make you wear masks, and you know what I'm saying? And
Yeah.
it's all kind of uptight, and you know, only so many people can go in there, and you're on a timer, and all that kind of crap, right? So I bought this membership to a local gym, and on Saturday, I coached some girls basketball. I helped, you know, with chores around the house, all that kind of stuff. And finally, it's Halloween, you know, and finally, at 8:30 at night, I'm like, I'm gonna go to the gym, okay? And so I run down to the gym, and they're freaking closed.
What?
I know. Who closes a gym on Halloween? It's like, oh, let's all eat candy. I mean, it just doesn't even meet the premise of going to a gym, right?
Yeah.
And so one of my former students is one of the managers for this chain of gyms. And there's nothing on the door that says gym is closed, you know? So I'm like, what's going on? Maybe they got shut down because we're in stage 3 of COVID or whatever,
Yeah.
you know? So I call him up on his cell phone, and he's like, no, they just closed for Halloween. I'm like, what's just wrong with you? He's like, do you want me to come open it for you? I'm like, what? He's like, I just live behind it. I'm like, sure. So he comes over, he opens the gym, lets me in, and says, just turn off the lights and check the door for lock. I had this whole gym to myself. It's the coolest experience. Dude, I went flash dance. I was like, he's a maniac, man. I was like dancing in front of the mirrors. Every time I do a set, I grunt like, ugh, you know, which I hate when people do that at the gym. Cause I'm like, you know, I would never do it because I'd be like,
Yeah, but if nobody's there, you do it.
Don't want to draw any attention to myself. But I went crazy, man. I turned on the stereo in there, blasted music, you know.
Hopefully the cameras weren't on.
Maybe I should have left my shirt on. I'm just kidding. Anyways, it was a blast, man. I told that kid, I'm like, you don't know what you just did for an old man, dude. I just had the funnest night of my life here. This was great.
It's pretty good.
Okay, did you graph this? So if you take y equals 3x minus 1, okay? I'm not going to do this for you, okay? Give me a point that one of you discovered for this.
0.
What?
0.
0? What do you mean? Oh, that's only one. 0, 0?
Sorry, 0 and it.
Oh, you put in 0.
1.
And what'd you get?
-1.
Okay, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So you got 0 this way and -1 this way. Okay, cool. Jackson got that. Anybody else use that same point? Say woo if you did.
Woo.
That's a good choice because 0 is always a fast one, right? What's another one? Lydia, you raising your hand?
6 and 5. Well, I got 6 and 5.
6 and 5, okay. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, we're gonna go 5 here, right? And that right there?
Yeah.
Yeah? And so, would you guys agree that, you know, your line looked like that when you graphed it? Did it look like that? Okay? All right, so we come back to this 2, 9, we go 1, 2, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9. You know, is that point on the line? No, it clearly is not. Okay, we cool? So, here's the deal. You got, let's do this one. You said you got 1, 2, 3, 4, 6 and 5. Is this what this one was? Okay, so then you got 6 and 5. Is 6 and 5 a solution to this equation? Well, we come back here. Where there is an x, I'm sorry, where
I
6
think
and
it should
5?
be 2, 5.
Yeah.
What, oh, 2, 5?
Oh, yeah, sorry, yeah, my bad.
Oh, okay, so this, I asked you guys if this looked like your graph, and you all nodded your heads, and, you know, I could sell you guys the Golden Gate Bridge today, couldn't I? Like, hey, you wanna buy a bridge? Like, you got your debit cards? Let's all put some money in on this, okay? Okay, check it out. So this is not the way your graph looked? Okay, you know what's interesting? All we gotta do, come up here though, this is what's kinda cool. 6 and 5, where there's an X, we put in a 6, so we got 6, and where there's Y, put in a 5, and we have -1. 3 times 6 is 18, 5 does not equal 17, does it? So that point is not on your line, right? That's all you gotta do to understand this, okay? So here we go. What point was it, Lydia?
2 and 5.
1, 2, and 1, 2, 3, 4, 5. So we come here, and now we go, oh, that's a good line. Okay, something like that, yeah? Okay, did your line look a little more vertical like that? Say yes or no.
Yes.
Yes.
Loud.
Yes.
Yes.
Okay, good. Okay, and that one there, it's close. Okay, but it's not on your line. Okay. All right, so we could put in 2, 5. So if we put in 2, 5, then where there's a 5, we have a Y, we have a 5. Where there's an X, we have a 2, and -1. So 5 equals 6 minus 1D, 5 equals 5. Yep, that's a point on my line. Okay. Yes.
So, any number that we will choose to plug in that will make the equation work will have the same like way that the line is drawn there, or there's like a slight differences. Does it make sense?
Yes.
Okay.
It does make sense to me, but I'm thinking of how to word it for everybody so it makes sense for everyone, okay? So, I speak of your language is what I'm saying, okay? I speak that math, okay? But, okay, what I'm trying to get you guys to do today, and sometimes you don't completely grasp it, I really want you to see, okay? I want to go back to something we discussed last time. Let's come to this board over here, okay? Let's come to this board over here. Okay? This is the equation, 2x plus 3y equals -6, okay? We graphed it over there, okay? And here I have it graphed again right here, okay? How many points exist on this line? How many? Infinite, okay? And every point on that line makes this equation true. Every ordered pair, okay? So you pick a value of x, and we gotta understand something. Let's say we change something. Let's say that this right here, Mauricio, let's say that the x-axis represents time, okay? And this is 8 a.m. and 9 a.m. and 10 a.m. and 11 a.m. and 12 p.m. and all that kind of stuff. Let's just say it's time, okay? And this is the amount of water left in your water heater, okay? And so we could say this right here, this is why, we'll say it's volume, okay? Now I got 6 kids in my family. On Sunday morning, yeah, it's just a steady drop off, okay? And so what I'm saying is we are losing capacity. You know, we're going in at, you know, literally by 5 a.m. we're in the negative range. Just kidding. Okay, good. We're losing it at a steady rate, okay? So here's what's up. But when I say x equals 8, where am I on my line? I'm right here at this point. There is a distinct value. For every value of x, there is a marriage to a value of y. That's why they're an ordered pair. You can think of them as eternal couples, okay? They're eternally married. They cannot be separated. This is like temple marriages here, you know? They're just bound together for time and all eternity, okay? And so we come back to this, and we have this value right here. Here's one of our values. When x is 0, y is -2. So we have 0, -2. When, you know, x is -3, y is 0 right there. You follow what I'm saying? And so what you asked is basically, do they all follow the same slope? Is ultimately where you're going with that. Yes, they do. They're all following that same pattern of a steady amount of drop every single time. Okay? Okay, here's the deal. In your basics, come to the far right board. I want you to just understand this concept. that in the math world, we call it an equation. In the graphing world, we call it a line. In the math world, we call it a solution. In the graphing world, we call it a point on our line. Okay? And to test to see if something is a solution to our equation, come to the middle board. To test if something is a solution to our equation or a point on our line, we can take that value of x and y and plug it in. Okay? Simple as that. Let's quickly graph 8y plus 2x equals -4, and then we are actually going to be done. I know somebody wanted something about 15. We'll see if we can mess with 15. We'll take a quick peek here. Okay, we need to pick a value of x. What do you want to do? I say let x equal 0 to start off with. You guys cool with that? We talked about that. That's kind of our happy place. When we do that, we have 8y plus 2 times 0 equals -4. We will get 8y, this cancels, equals -4. Is the camera angle good here? We don't have any loss here. Okay, we divide by 8, divide by 8, we get y equals -1/2. And so my first order pair is 0, -1/2. Okay? We can handle halves. Okay? Let's pick something else. 2? Okay? So I'm going to share this with you. I want to pick 4. You want to know why I want to pick 4? I'm trying to avoid another fraction. I want to get a little further away, but you can pick 2. I'm cool with that. Okay? So we'll take 8y plus, so we'll say let x equal 2. 2 times 2 equals -4. We might avoid a fraction here. That'd be cool. 8y plus 4 equals -4. We subtract 4, we subtract 4. We get 8y, this cancels out, equals -8. Divide by 8, divide by 8. Y equals -1. And so I have 2, -1. Okay? Now the only thing that will be a challenge with this graph is that these numbers are pretty close together. And so we're not going to have a whole lot of distance, so our accuracy will be compromised a little bit. When I'm drawing a graph where I have a half, okay, I might want to make my hash marks a little further apart than normal so that I can, clearly see the half mark. Okay? So I go 0 this way and down -1/2. I'm right there. I go 2 this way, I go down 1 right there. It's a very flat line. Okay? Slope is really minimal on that one. There's your line, and you're done. Okay? What was it, number 15 also?
19.
19? Okay. What is 19? Help me, Obi-Wan Kenobi, you're my only hope. It says the first and second coordinates are equal. What's this? In which quadrant can the point described be located? The first and second coordinates are equal. Yeah.
The first quadrant, third quadrant, because they're both positive in the
Yeah.
first quadrant.
You could get confused by this, but for sure, let's look at this. Let's come to this far board. So here's quadrant 1, here's quadrant 2, here's quadrant 3, here's quadrant 4. Okay. It's not saying that all of the coordinates or ordered pairs would be equal, but here you have a positive and a positive. Here you have a negative and a negative, right? Here you have a negative and a positive. Here you have a positive and a negative. These can never be the same because one will always be positive, one will be negative. Here, the signs are the same, so you're absolutely right, Jackson. These are the only quadrants where your coordinates can be the same. Okay? All right, enough questions from last time. We've taken a lot of time, but we've also lectured over some stuff today about basics. Okay? I want you to open up your page in Notes to Graphing. We're going to dive in. I'd like you to join me real quick. I lied. I want you to go to the basics. Okay, sorry. Go back to your basics page in graphic. I'm sorry, in graphic basics in this chapter. Basics page. So, anybody watch any football yesterday or this weekend? Yeah? What'd you watch?
Every game.
Every game?
Yeah.
Every
have a
game?
Sunday ticket, which is like every game basically.
Yeah, I have it too. I like it.
Let's go.
So I'm in a Bishopric on campus, and to be honest with you, I got home at 5 p.m. last night, and I was there all day long. So I don't get to watch all my NFL ticket, but I record some games, and I'm a big Seahawks fan, so I love the Seahawks. They did good yesterday. When a quarterback throws a ball, okay, for those of you who don't know football, I'm sorry, but when a quarterback throws a ball, he or she is intending that ball to go into the hands of one of their receivers. People who can catch that ball could be running backs, they could be wide receivers, they could be tight ends, all that kind of stuff. Those are different positions. But when a defensive player jumps in front of that and catches the ball, what's it called? Say it loud.
Interception.
An interception, okay? I hate to break your hearts, but the word interception is not a football term. It's a mathematical graphing term, okay? It's existed long before football did. And what it is that, when you have a line, and so we can take the quarterback throwing that ball to the wide receiver, but, the corner, we call the cornerback, the CB, okay, jumps that route, and at just the right moment intercepts that trajectory of that ball. You have at this point, you have an intercept where two lines cross one another is an intercept, okay? There are two intercepts that we are incredibly interested in working with lines, and they are the x-intercept and the y-intercept. And so in your basics right now, go ahead and draw this with me, okay? You have your x-axis and you have your y-axis. By the way, just for good practice, and Mauricio, you definitely inspire this conversation, and I don't want you to think I'm claiming that you don't do this, but I just want to share this one thought with you, okay? Merely taking pictures in class is not note-taking, right? That's photojournaling. And that has value, because you can go and you can reference that. That's great. But we talked about this, the power of writing. I had you draw a doodle one day in class. I talked about how that's even the power of creation. You created something that didn't exist before. You do need to write things down. It leaves an indelible imprint upon the brain. It's part of the kinesthetic power of learning. Okay, so make sure that if you are just simply taking pictures, that you then follow up by writing down your notes. It becomes really imperative to learning. So if we have a line, okay, and we can just make up any line here. We'll go ahead and use this red pen, okay. That red pen kind of stinks. Watch out, David.
Do it. Intercept it.
Oh, I made it.
Let's just go in.
You know it.
It's good.
That's what happens when you go to the gym all by yourself. You get super confident, Nobody's there that's bigger than you. Every time you look in the mirror, you feel swole. You know what I mean? There's no one there to defeat you. Okay? Okay. So we have this line here. And at this point right here, and there's no hash marks, it's not really critical. And at this point right here, we are crossing axes. Okay? And so this point right here is where we're crossing which axis?
X.
Yeah. And so this is known as our x-intercept. All right? And the x-intercept is an ordered pair. And I need you to understand, again, how many points exist on this line? Infinite points. Infinite points. And every point has a what and a what coordinate? An x and a y coordinate. But the x coordinate, where we cross the x-axis, we give a special letter to it, a special designation. We call it A. And I know this is going to confuse me. A is still x. Do you understand that? A is still the x coordinate. But we give it the letter A because if there are infinite points on the line, A will be the one x coordinate where you cross the x-axis. Okay? And this right here, this one right here, is always what?
Or Y.
Right here. Think about it. This is our value of y, and where are we right now? What's our value of y right here?
0.
It's 0. And it's always 0, because if it's not 0, we're not on the x-axis. Right? It's always 0. So this will always be 0. Okay? And this is some of your basic knowledge you have to have. Okay? So let's think about this. Okay? And by definition, the x-intercept is where our line crosses the x-axis. Okay? So this right here is our what? It's our y-intercept. Agreed? It's where our line is crossing the y-axis. And so we're going to define that, where our line crosses the y-axis. And so this also has an ordered pair. What's the x value?
0.
That is right. It is always 0. Okay, so this is always 0. It has to be, or we wouldn't be on the y-axis. What do you think we're going to call the value of y in this one? B. Yep, this is b. And so if you ever heard the equation y equals mx plus b, b represents the y-intercept, okay? Write all that down. That's really critical for you to understand in working with lines, okay? And that goes under basics. The next thing I want to do is I want to talk about, we're going to jump to our graphing page. And so we talked about how there are 3 methods of graphing. So graphing method 2 is called the intercept method, okay? And you can write while I'm writing, okay? And how many points do we need to graph any line? How many?
2.
Louder.
2.
Everybody.
2.
3?
2.
Why don't we want 3?
It's a waste of time.
It's a waste of our time. How about 1? Why not just 1?
It's not a line. You need 2 points.
It's just a dot. We've got to have 2 to connect those dots, right? So we need 2 points. So to find our 2 points, we're going to put up here need 2 points, because that's just, I don't know, that's like saying humans need air, you know? I smoked a bunch of that this morning. I don't know if I got enough. I'm feeling a little lightheaded. Did you get enough?
Gotta work on it. Yeah.
Yeah. Okay. Step number 1, we are going to find the x-intercept. Okay. In order to do that, step A, we are going to set y equal to 0. Look at this right here. That's because to have my x-intercept, y has to be 0. So we're going to set y equal to 0, and we're going to solve for x. Okay? So think about that. In the past, we did plug and chug. It's very similar to plug and chug. We pick a value of x and chug out a value of y, but now we're going to, instead of picking values, we're going to set one variable equal to 0, solve for it, and then do the opposite. Set the other variable equal to 0 and solve for it. So our first step is to find the x-intercept. Well, that would only give us 1 point. So what do you think we're going to do in our second step? We're going to find the y-intercept. And step A says we are going to set x equal to 0. And B, what are we going to do? Solve for y. Jackson's got this, man. He's on it. He's thinking. Okay? And then our third step is basically the same thing as, and, we're going to plot the dots and connect them. We are done. Okay. So let's come to the middle board here. I apologize that at home you can't see both right now. But we're going to take the same equation, 2x plus 3y equals -6, okay, that we've had and been using, throughout this discussion on lines. And we're going to do step number 1. So I want you guys to join me right now. We're going to do 1 together, and you're going to do 1 on your own, okay? So our first step number 1, is we're going to let y equal 0, because we are finding the x-intercept right now, okay? So we will take 2x plus 3 times 0 equals -6. This cancels. We get 2x equals -6. We divide by 2 and divide by 2. We get x equals -3. What's my first ordered pair?
0, 0, -3.
Think.
-3, 0.
Thank you. You were saying 0, -3. Remember, y is now the value that we've designated for 0. So we got in this habit in the plug and chug method of the first number we put in was x. We have to think about this. We got to be organized here. We got -3, 0. That's our first point. Do we have enough points to graph a line right now? No, we need the other intercept. So step number 2, we're going to find the y-intercept. And so we're going to let x equal 0. And then we're going to take 2 times 0. In fact, I'm going to do this to stay a little consistent here. We'll go 0. Okay. And we'll have plus 3y equals negative 6. This cancels, we get 3y equals negative 6, we divide by 3, we divide by 3, we get y equals negative 2. So, what's my next ordered pair?
0, -2.
Now we have 0 first and negative 2, okay? Think about this. We said that this was a comma 0, and this was 0 comma b, and it makes sense. So a and b are still values of x and y, but they're the one value of the infinite values on a line that represent where we cross our axes. A being the x-axis, b being the y-axis. We cool? Now we got to plot those two dots, so we're going to draw our graph. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Negative 3 and 0. It's this one right here. 0, right? Did I do that one right or wrong? Negative 3, 0 this way. This one, 0 this way, negative 2. Connect my dots. There we go. I want you to pan over here, Kenny. It's the same equation. Look at this, and then go back to that. And look at this. Okay, and then go back to that. Okay, are they the same graph? So what we did with the plug and chug method over here, letting x equal 0, letting x equal 3, we can do with the intercept method. Now somebody may say, hey, Brother Rich, I like this method better. Why didn't we just learn this last time? Why were we fetching around with all these different values of x? Okay. In graphing, there's more than shapes than lines. And plug and chug is kind of a staple method that we learn to graph all kinds of shapes and objects. And it becomes requisite in different circumstances. Why do we learn the intercept method? So that we can learn how to find intercepts. Finding intercepts is really important. Please look up here, okay? If this graph represented money over time, at this threshold right here, our company began to lose money. We dropped into the negative zone. This is time, this is money. And so intercepts become points at which great value of knowledge is gleaned, okay? An intercept crosses some kind of a threshold where, we started having, too many cases of COVID. Hospitalizations began to overrun the number of beds that are available in the hospital. Profitability, becomes a positive range or a negative range. Intercepts are these thresholds at which we cross some line of value, okay? So intercepts are really important to know. But here's another thought, okay? What if I have an equation, okay, where, well, I'll give you an example here in a minute. Let's have you do one on your own for just a minute here. I'm going to have you guys right now, I'm going to have you graph. It's always fun putting your glasses over there.
You need a prescription shield.
Oh, a prescription shield.
You
All right,
switch it out or something like that. It'd be like a
just use my
visor.
X-ray vision.
Yeah.
Yeah. Okay. I want you guys to take 2x plus 6y equals 12. Okay. I want you to take 2x plus 6y equals 12. And I want you to graph this using the intercept method. Go ahead. Find the x-intercept and find the y-intercept. And then graph it. So for those of you who are here today in class and those of you who are at home, did you get my email this morning? This week, we're just coming to class. There's no this amount of people are not coming or that amount of people are not coming. You want to come? Come. Okay? We have in here today 1, 2, 3, 4, 5, 6 empty seats. I really don't think we're going to have a problem for the rest of the semester. So right now we're gonna experiment with it this week, but we're just gonna, if you wanna be in class, come to class, okay? So hope you got that message. Are those the intercepts that you're getting? Is this the answer to this problem? No? Yes?
No. On the 3, 0, I got 6, 0.
I did too.
Yeah.
I couldn't read through my. Thank you. 6-0. I like it. Okay. Is this method hard or easy?
Easy.
Do you like it?
Yes.
Yeah. I think it's a cool method. It's rapid. I love working with zeros because it just makes the math pretty fast. Okay. Because you're eliminating one of the variables. So you plot these two. By the way, what intercept is this? Let's think about that. What intercept is this?
Why?
Okay, just for your knowledge, the one with the numerical value, so this is your x and this is your y, the one with the numerical value is the intercept you're finding. So this is the y-intercept. This is the x-intercept. So I put them in opposite order, just almost to confuse you, just to be like, so you just, they want, oh, that one's the x, that one's the y, okay? All right, so we plot these. We got 1, 2, 3, 4, 5, 6, we're right here, agreed? And 0, and then we have 0 and 2 right here. And so this line went like that. Did that look like your graph? Okay, cool. So one hiccup emerges from this method. Do you know what it is, Brother Shaughnessy? The hiccup that emerges from this method? Don't reveal, just say yes or no.
Yeah.
Do you know?
Yeah.
You do.
Yeah. It's when the y-intercept. Wait, you don't want to tell me.
I don't want you to.
Okay,
reveal it.
shh.
You're a math teacher.
Shh.
Gosh, man.
No, I just taught this, and Kenny was like, "There's one problem with this," and then we did it.
Okay.
Right, Kenny? It was good.
I want you to graph the following equation right now. X plus 2y equals 0. X plus 2y equals 0. Okay? Go.
Are you using the same method?
Yeah. Try to use this method. You did. Good. Did you know, I threw that pin over the barrier, over the defenders,
It's good.
into the bucket, man. Have you pulled that off?
No, I always do it backwards.
Oh, you throw them behind your back.
Yeah, and I never make it.
I never make it. Brother Shaughnessy and I have all kinds of fun competitions.
It goes off. I always hit the wall. Well, I shouldn't tell you what I usually hit.
And any markings, any markings on the roof, on the walls in here, the two of us have pretty much damaged. and
Every
destroyed.
so often I hit the ceiling.
We were the children that our parents were like, oh, he's moving out, thank you. We can finally remodel. Okay.
I've only had a student twice.
Okay, are you guys running into any difficulties with this? What's your x-intercept? Now, when I ask you what an intercept is, I need to know the ordered pair. What's the x-intercept? It's 0, 0. What's the y-intercept? Do you understand that if x is y, or if x is 0 and y is 0, that constitutes both the x and the y-intercept? You don't even have to do any further work. If you chose to put x in for 0 and you chugged out a value of 0 for y, and then you plug y in for 0 and chugged out a value for x is 0, you were being redundant. That's good. It's okay. But just know, if you plug in 0 for x and y equals 0, that means that that's a married couple. That means that if x is 0, y is 0, well, guess what? You already know if y is 0, what x is. It's 0. Back and forth. Okay? So here's the problem. How many points do you have? You only have 1. So you have to revert to what? The plug and chug method. Absolutely. So there's another reason why we have to know the plug and chug method, because the intercept method does have, a failure in it. It does not cover when we cross this point here. Okay? So you have 0, 0. So let's pick a value for x. Let's pick a value for x real quick. 2. Okay? So if I say let x equal 2, I'll have 2 plus 2y equals 0. Subtract 2, subtract 2. Okay, 2y will equal negative 2, divide by 2, divide by 2. Y will equal negative 1, so I will have 2 comma negative 1. So I can go 1, 2, and negative 1, and right here. And so this line looked like this, okay?
I don't think you did.
No, it's not true. Why not? What did I do wrong? What did I do wrong?
Did you graph it right?
What's that?
You didn't
Say it louder.
Yeah, you
You
didn't
didn't
graph.
graph it right.
Okay, this is the #1 mistake that students make on the test. Brother O'Shaughnessy is another math teacher. He's nodding his head, okay? Graphing is hard or easy, everybody? Hard or easy? It's easy, but we have to be thorough and organized. Our first movement is our X movement all the time, and I see students get mixed up consistently with this, okay?
And
So-
we have that answer on the test.
Oh yes, we have the wrong answer on the test, guaranteed. We definitely will mix it up and reverse it for you. So we have to go 1, 2, negative 1, like this. Agreed?
Yeah.
And now there's my blue line. Okay? Does that look more like the graph we should have? Absolutely. Okay. Okay. Finish taking notes, take any pictures you want on this. We're going to jump into a new topic, and we're going to go to our basics notes again. Okay? Has anybody in here, I want to ask you, I sent out a couple of, messages with links to Brother O'Shaughnessy's YouTube videos that he's been doing in class. Has anybody looked at those? Raise your hand. Has anybody in here looked at those? Okay, so nobody in here has chosen to look at the YouTube option versus the Zoom option. Okay, so Chelsea, you're raising your hand. Yeah? Can you come off mute? Yeah, so, was the YouTube more quality? Did it help?
I think so, because sometimes the Zoom, like when you use the Zoom, it doesn't let you I don't know, skip ahead or go back. Like on my devices, it doesn't really want to work
Okay.
very well, but I kind of find it a little more useful.
So one of the reasons that we did this, that's good to know. That's kind of a technical thing. One of the reasons we did this was because visual and auditory clarity were lacking a little bit on the Zoom recording. Like in class here, I'm hearing, hey, the visual is good, the auditory is good, but when you send that recording to us, it's a little more blurry. The auditory, is a little bit, more distant. Has anybody checked that out? Because I don't want to keep doing this if nobody gives a crap. Brother O'Shaughnessy's laughing. If you're not going to use it, I don't want to record it twice. You know what I mean? We'll do it 1 or 2 more times, but would you guys just take a look at that today and just take a peek and see if you're like, hey, I want to use this. But if you're like, I don't really use this resource much, then we're going to just let Zoom do its thing and we're going to move on. Is that cool? You agree, Brother O? Yeah?
Hannah said she looks at it and it's much better.
What's that?
Hannah said it's much better. on
Hannah?
YouTube, yeah.
You're saying it's much better? Okay. We'll believe you. You're the only one. You're kind of like Obi-Wan Kenobi. You're the only one. You're my only hope. Okay. We have about 8 or 9 minutes of class left. We need to discuss something else that comes up. Okay, can I erase the middle board? You guys good? So your homework tonight, I'm gonna try to go publish it in between class. It is going to be, but I won't have the Zoom link to it, so it is gonna be 1 through 59 odd. Okay. So it's going to be section 3.2, 1 through 59 odd. You can just follow the directions. They tell you to graph by finding the intercepts. That's the method we're using today. Please don't use plug and chug, okay? In order for us to learn the 3 methods of graphing, we've got to use those 3 methods. You know, you got to meet the information halfway. This is your part where you're coming to the information through doing the homework assignment. So we've done the plug and chug method exercises. We're going to do intercept exercises tonight. But you're going to run into something, and it's basically this. Let's draw our attention up here. I'm going to tell you to graph x equals -2. X equals -2. Go ahead and graph x equals -2 right now. I'll give you about 30 seconds. Go. Draw a graph and graph it. Okay, how many of you did this? How many of you just did that? Okay, raise your hand if you did that. Let's see at home. Okay, how many of you did this? Raise your hand if you did this. Okay, this is correct. This is not correct. No FUMAR. But class is a safe place to make a mistake. This is a very common misunderstanding of x equals -2. If I wanted you to plot a point, I would have told you to graph, look up here, this is graphing -2, 0. That's what that is. If I told you to graph this, that's a point. But the equal sign means I have an equation. An equation, come back over here to this board, an equation is a line. An equation is a line in the graphing world. In the math world, it looks like this. But in the graphing world, it's a line. So let's come back to the middle board. I have an equal sign here. So that means that this is an equation. So we need to talk about horizontal and vertical lines real quick. Horizontal, I think I'm going to erase the far right board and make a little chart over here. We'll use both boards. I don't want to try to cram all this in here. So we're going to have a little chart. This goes under your notes, under basics. So we're going to again talk about lines, and we're going to have horizontal. You can write this while I'm writing. This goes under basics, and we have vertical. And we're going to talk about their graphs, okay, and their equation, and their slope. And so the graph, in fact, we're going to drop these down a little bit here and give us a little bit more space. Equation and the slope of these. So next class period, we're going to be focusing on slope. But the graph of a horizontal line, okay, really depends on its equation. And so, and we'll have what we call the example. Okay. So the equation of a horizontal line, well, check it out. It's going to be y equals b. That's just kind of, you know, like, what? You know, what does that mean? Well, an example would be y equals 3, okay? If I have an equation where I just have the variable y, all right, well, let's graph this. We go on our y-axis, and we have 1, 2, 3, and we find that right there. We graph it. And we're done. It's a horizontal line of y equals 3. I want to show you something interesting. Everybody help me out here real quick. What is this point right here? What's that point right there? Tell me the coordinates of that point.
0, 3.
Okay? 0, 3. How about this point right here? What's that one? 3, 3. How about this point right there?
-2.
-2, 3. What does y equal on every point?
3.
There you go. So the simplicity of this equation is telling you every point y equals 3. In a vertical line, we have, on our equation, we're going to have x equals a. An example would be x equals -2. We come down to x on the x-axis, 1, 2, right there, and we draw this vertical line. We can play the same game. We can do this, we can do this, okay? What are my coordinates to this point right here, quickly?
-2, 3.
Okay, so we have -2, 3, -2, and -3, okay? What's this one?
-2, 0, 2, and 0.
Okay, -2 and 0, and this one right here?
-2, 2.
-2 and 2. So what does x always equal? -2. Same kind of a concept there. We'll save slope for next time. We'll leave this part empty. So here's the deal. When you are asked to graph an equation and you only have one variable, okay, so we're gonna write this down, our notes. When graphing, if I have an equation with only one variable, I have either a horizontal or a vertical line. Okay? Now it behooves you to memorize which one is which. Look up here. It's very interesting. The horizontal axis is which axis? It's the x or the y axis. The horizontal axis is the x or the y axis.
Y.
Horizontal. It's the x-axis. Interesting that the equation is a y statement. It's the opposite of the axis. You're going to have to do what is best for you to memorize this. But at the end of the day, if you get confused, pick 2 points where y equals 3. Here, pick 2 points where x equals -2, because you need 2 points to graph a line. You got an equal sign, you got an equation. You got one variable, every time, just x equals -2. Here, connect them, and you'll be good to go. So the latter part of your homework tonight is, just graphing horizontal and vertical lines. Okay, I want a minute of your time. Okay? So, I'm 50 years old. I've been teaching here, I've been teaching for 25 years. If I get fired for taking my mask off today, if you decide to turn me in, that's your deal. We are socially distanced. I'm about worn out with all this COVID bull crap. I'm sure everybody is. I've had COVID. I'm immune. I can't transmit it according to Eastern Idaho Public Health, and I can't get it. But every day I gotta come here and wear a freaking mask. I serve in a bishopric on campus, and the bishop says, "This sucks being up here." Well, I've never known any different. I got called into the bishopric the week that COVID hit. So I think it's really cool to be in a bishopric on campus. But I have been teaching here for a long time. And I'm gonna tell you, teaching this semester, it's not fun. You guys never talk, you never smile, because I can't see it. You're muzzled behind the mask, I've talked about it. I have more students not take and fail the Chapter 2 test than I have in 25 years of teaching here. One student got 100%, one, and that student is not in this class. The overall grades were mediocre, and that's on you, not me. I'm teaching the same information, teaching it the same way. I've been known as a teacher who can drag you across the finish line through humor, through fun, but this is getting really nasty and old. I'm just like, really? This is what this is going to be for the next couple semesters? Guys, I need you for yourselves to do better than what you're doing. I'm going to extend the chapter 2 retakes through Friday. If looking at my face without a goofy reflective mask makes it more motivating, I'll tell you, looking at you without yours would make it more motivating for me, but we're not going to be able to do that. But I need you to dig deep. I totally understand in this age of Zoom and COVID that it's really easy to disengage. But I want to start with where we started at the beginning of this semester, and here's what's up. You ready? Nowadays in sports in the United States, everybody wins. They give every kid a medal for participation. Let me tell you, in life, there are no participation medals. You either win or you lose, and that's the bottom freaking line. And you're in college to make yourself more competitive in that work environment. If you lose now, that's not good. This is a beginning algebra class. It's the equivalent of a junior high school course. You have raised your hand and said, I'm not ready to handle college level math. We began by doing the R chapter in chapter 1 to show you that you can succeed. Some of you got lulled to sleep and thought, this is easy. I don't even need to show up. I'll check in now and then. Now you got to chapter 2 and you're like, oh crap, this isn't as easy as I thought it was. You have through Friday to retake this test. Many of you, and most of you, should retake the test because you're better than the grade you got. Just because you got an 80%, don't live with that. Retake it. Try to get an A. Try to get 100. Try to be better. For the 5 or 6 people that didn't take the test, I reach out to you and I say, you've got till 5 o'clock today to reach out to me. If you don't, you fail the class. I'm done playing games. Stop using COVID as a crutch. I don't want to hear any more excuses. It's time to man up, woman up, and buck up. This is your life. Grab the steering wheel, okay? This is an opportunity to have success in something you're not good at. I'm here for you. I will teach my guts out. I'll try to make it good and palatable. Raise your hand if I've helped it be more understandable than it's been in the past for you, okay? Every hand's gone up. I'm doing my job, okay? I try to make it fun as well. But these grades that are existing right now for the Chapter 2 test, that's on you. That's not on me. And it's not acceptable. And you can't accept mediocrity right now. You need to dig deep. And I know you have it within you. You are winners, okay? And it's time to win, okay? Because again, there are no participation points in the working world. You know, you win or you lose out there. And we're training you to be winners in here, okay? And that's the reality. I love you guys. I would bend over backwards for you. I would do anything for you. But I can't help you get motivated in the age of COVID. That's going to have to come from within. And I'm sorry. I wish, to be honest with you, I'm going to tell you this. Do you want to know the number one way to succeed in this class? Get your butt in here, if you can, physically. It's the reality. I created this program at BYU, Idaho, 25 years ago. 80% of students taking Math 100B in the nation fail this class, and that number has not changed a lot. 80%. That number has not changed a lot in the last decade. They're maxing out at 40, 50% at some schools, and they're running a victory lap. Woo! Not even half of their students are passing this class, and they're singing victory because they've doubled their success rate. 90% of our students pass this class at BYU, Idaho. 90%. This is the best program in the nation to help you if you struggle with math. But I got to tell you, I founded this program on some very simple concepts. If you suck at math, you can't teach yourself out of a book. If you suck at math, you need a good teacher. If you suck at math, you need to supplant good teaching with tutoring. Bottom line. If you suck at math, you got to do your homework, you know? So really, truthfully, if you can be here in class, it's going to help you. You're going to be more motivated. You're going to get more done, okay? Handing in homework physically, believe it or not, is actually better than handing it in with a file upload. It physically holds you accountable. But the reality is that through COVID, we have to do it in these different ways. I told you the story about my kids, and it's time to go, and then some. I told you the story about my kids when COVID came, and I said, this is your time to rise up, because this generation, this is gonna be a loser time for a lot of kids when it comes to school. Don't be in that statistic, you guys. Don't be in that statistic. We do have to do file uploads. We do need to be remote, and we have to have Zoom and all that kind of stuff. But I encourage you, if you want to get better in here, try to physically come. But if you can't do that, for whatever reason it is, dig deep. We got half a semester left. It's time for you to be successful. It's time for you to win. And I'm here to help you. I'm your coach that can take you to victory, okay? You guys have a good one. We need to discuss what math class to take next. And I'm behind on that because registration starts tomorrow. At the beginning of class on Wednesday, we're going to spend 10 minutes talking about what math class do you take after this, okay? And we'll have that discussion to guide anybody who wants some guidance in that. In the meantime, sign up for a Math 108 or a Math 101 class. If your registration time comes, you can drop one of them if you need to, and after our discussion. You guys have a good one. Get that retake done. I'll talk to you on Wednesday.